What I've built today is an audio effects processor. So I've taken the audio slice, so this gives us an ADC and DAC, and I've plugged it into our board, and then basically what we got is analog in and analog out, and in between you can put in whatever you want. So in this case we've got a set of effects, so you can choose different filters by pressing this button. And the other thing I've got is on these sliders here, these capacitive touch sense sliders, I've got another effect for those who enjoy technology, which is a Dalek voice transformer, a thing called a ring modulator, which allows you to play with the depth and frequency of what's called an LFO, which allows you to modulate a voice to sound like a Dalek.
Got here this morning, was up and running with the kit within 15 minutes of having the hardware, and yeah, just been looking at it since, seeing what the example applications do and seeing if I can understand a little bit more in depth as to what the code underneath it's doing.
There's obviously an LCD screen that I've attached to the slice kits, so that's the LCD slice. So the X-Core's kind of driving that. There's a task which manages the kind of frame buffers for kind of drawing sprites on the screen. And then there's a task which emulates the kind of the CPU of this chip 8. So there's a kind of instruction set. It's kind of sitting there, kind of emulating those instructions. As a result, kind of drawing on the screen.
We've got a lot of flexibility in the programs you can run and the I/O you can connect to it.
I have just this small startKIT with the additional wireless slice. And when I push the button here, you can see on the other startKIT that the LED is running, and when I release the button, then the LEDs are no more running. That's a big success for today. It looks very easy, but it was hard work before.
Very easy to use. Software, very easy to install, very easy to get something running. Some nice example code that just works.
I'm just playing with the accelerometer slice that we have developed for it, and doing some experiments in visualization of the data that we get from that. So we have a small demo that runs on the startKIT itself using the LEDs to represent sort of where a marble might be if you were to roll it, and I'm just doing some extracting that data over the Xscope link and then visualizing that on the screen.
There aren't many things that would easily allow you to do what the XMOS chip allows you to do.
What I've been doing is driving a couple of H bridges from the startKIT to drive the motor in the missile launcher there. This piece here is the Wi-Fi slice, which is connected to a Wi-Fi network here, and then we can then control the motor via Wi-Fi. So we've been doing this 6 or so hours, and basically got the basic movement working, a simple web server running, but yeah, not too long really.
There's nothing hidden. You're kind of interacting directly with the hardware, and also you can kind of make a change and see that change and how it affects what you're developing straight away.
It's supposed to be a flanger effect, but I have some issues with arithmetic overflow here, so I get clips and distortion. So some more debugging required, but I can already control the frequency of the effect. So here's the lovely distorted audio effect, and now I can use the capstan slider to change the frequency of the sweep. So it's a slow sweep, and I'll swipe the other direction, and I can increase the frequency. Of the flanger sweep. It's not much of a flanger, as you can hear, but hopefully we can sort it out with a debugger tomorrow.
Yeah, there's all sorts of things you can think of that you might do with it, and the little add-on boards you can have. You can develop your own, you can use some of XMOS's standard boards, so yeah, you can think of all sorts of little things you could develop and play with and show to the world.